Hi, in this video I'm going to try to explain how blockchain technology is working. I'm basing the information I'm giving you in this video based on this video from Andres Brownworth. I hope I'm pronouncing his name correctly. If you want to watch the original video, you're more than welcome, but in this video I'm going to try to break it down in more simple to understand way using Jenga blocks. So without further ado, let's begin. So the way the blockchain is working is fairly simple. In the video that Andres is showing, he's giving the example of if you take the blockchain and equivalent to actual Jenga block. Each block has a certain amount of transaction that you can put inside the block or any data in that example. If you look at the video, he's trying to explain it in a very simple way. Let's say there's limited amount of characters that you allow to input into the block. Now, every block has what's called hash number. Hash number is basically some kind of a code that's identifying the block itself and unique. The interesting thing about hash is even if you change one character inside the data that's in the block, it's going to change the actual hash code that identifying the block. Now, furthermore, each block also have some kind of a serial number, a running number that showing on top. So there can't be any two exactly the same blocks with the same serial number. So as we said, first of all, the first thing that identifying a block is the hash number. And the second thing that identifying the block is the nonce. That's how he called it, nonce. I would call it a serial number, so you better understand the example. Now, let's dive into the block. So on the block, it could be anything, the actual data that's showing inside the block. It could be anything. It could be a line of code, a ledger of transaction, A transferred to C, transferred to B.
But more specifically on the Ethereum blockchain, what's been stored on the blocks is the ledger of transaction. Whenever there's a transaction happening in the cryptocurrency, it's been recorded and uploaded to the blockchain.
Let's try to make it simple. Let's say God created one Bitcoin and transferred it to Adam. Adam transferred it to Eve, and Eve transferred it to Cain, and Cain killed Abel, and Abel transferred the money to Cain. So Cain had most of the Bitcoin that was exist back then. The list of transaction goes on. Point is, the blockchain contains all this data information, and each line has been written on the block. So far, we understand that if we write all the transaction on one block, it's probably going to be one place for data to be stored. But since we have limited amount of space on that block, we need to create another block. So we put this block aside, and then we get another block. The way that this block is going to be attached to this block is very simple. Just like this block has a hash number or barcode, unique barcode that identify it, this block also has a hash number, but it also has the hash number of this block. So it's basically pointing out chronologically. It says this block has this number, this barcode, but it's also coming right after this block. So in order to identify this block, it will have the actual hash number of itself and the hash number of the block before him. That way, we already know which block comes first. So we know, let's say this block is 0, this block is 1. As soon as this block is ran out of space, we add another block, and then another block, and then another block. And each one of them is basically has the same kind of concept. It has a serial number that's pointing out what's the number, unique number that's not been used so far. It could be any number. And it has also the barcode, the hash number of itself and what comes before him. And that way they build up together as a chain. Another block and another block. and more blocks. Let's say there's a hacker who's trying to tamper with one of the transactions that's located right here. Now let's say he's going to try to tamper one block, let's say this one. If he's going to try to change any data that it's inside that block, it's going to make the rest of the chain invalid. That's why every block that was already been written is going to be sealed. There's no way you can tamper with the data that's in it, because one, as I mentioned, one character change on the block, that's what's going to happen. What you see right here is the ledger of blocks. Each one of them is distributed to a node. That means this whole thing has been duplicated and been transferred to other people. So it's not just one computer containing all this ledger of transaction. It's all the computers that are hosting the same ledgers. Each one of them is holding the current block.